Welcome to this slide presentation for Seminar 6, of BUS8000, the Scholar Practitioner, which describes scientific inquiry and the dissertation research process.
If you expected science to give all the answers to the wonderful questions about what we are, where we're going, what the meaning of the universe is, and so on, then I think you could easily become disillusioned and then look for some mystic answer to these problems. We're exploring, we're trying to find out as much as we can about the world. People say to me, are you looking for the ultimate laws of physics? No, I'm not. I'm just looking to find out more about the world. And if it turns out there is a simple ultimate law that explains everything, so be it. That would be very nice to discover. If it turns out it's like an onion with millions of layers and we're just sick and tired of looking at the layers, then that's the way it is. But whatever way it comes out, its nature is there and she's going to come out the way she is. And therefore, when we go to investigate it, we shouldn't pre-decide what it is we're trying to do except to find out more about it.
There could be no better individual to introduce the idea of scientific inquiry than Richard Feynman, the American theoretical physicist who was probably the most brilliant, influential, and iconoclastic figure in his field in the post-World War II era. Feynman remade quantum electrodynamics, the theory of the interaction between light and matter, and thus altered the way science understands the nature of waves and particles. He was awarded the Nobel Prize for Physics in 1965 for this work, which tied together in an experimentally perfect package all the varied phenomena at work in light, radio, electricity, and magnetism. The other CO winners of the Nobel Prize, Julian S. Schwinger of the United States and Tomonaga Shinichiro of Japan, had independently created equivalent theories, but it was Feynman's that proved the most original and far-reaching. The problem-solving tools that he invented, including pictorial representations of particle interactions known as Feynman diagrams, permeated many areas of theoretical physics in the second half of the 20th century. In the next slide, Feynman, in his own words taken from his famous lectures on physics, describes the essence of scientific inquiry. Following that slide is a letter he wrote to a former doctoral student, describing how to identify research problems. In this letter, he summarizes Baker's approach, which is to have students identify their own dissertation topics and research problems.
Feynman said, knowledge results from the application of human reason to nature. It involves both sensible and rational factors in concert with one another. As Kant observed, perception without conception is blind, and conception without perception is empty. Experiences result from the natural interactions of organisms and their environments. The process of inquiry establishes a distinction between sensed data and interpretive ideas which serve as checks on one another. Knowledge is thus dynamic and is constantly modified by new experience or more finely tuned and directed questions. In turn, reason and experience form the basis of judgment about what is to be desired and enjoyed. This judgment of values is the basis of future action and thus the basis of future inquiry and the construction of new knowledge. The worthwhile problems are the ones you can really solve or help solve, the ones you can really contribute something to. A problem is grand in science if it lies before us unsolved and we see some way for us to make some headway into it. I would advise you to take even simpler, or as you say, humbler, problems until you find some you can really solve easily, no matter how trivial. You will get the pleasure of success, and of helping your fellow man, even if it is only to answer a question in the mind of a colleague less able than you. You must not take away from yourself these pleasures because you have some erroneous idea of what is worthwhile. No problem is too small or too trivial, if we can really do something about it.
Some studies are descriptive in nature and bring more detail to our understanding of particular situations. Some studies attempt to explain the causes of certain phenomena, while others explore the critical assumptions and values underlying our conceptions. Still others seek to discover the practical application of theoretical concepts to the world of work. In all these cases, the purpose is to add to our knowledge, and to fill gaps in our understanding. In the second year of the program, you will learn more about the research process. As indicated in the previous slides, the first step is to identify the research problem. Next, you need to develop researchable questions or hypotheses, which, if answered, would contribute new knowledge to our understanding of the problem. These questions grow out of a thorough review of the research literature and must be placed in the context of current theory. Once these questions are identified and clearly stated, a means to answer them must be developed. This is the research design. The design grows out of a conceptual framework or model, which typically includes at least two variables that operationalize the concepts. Data is then collected and analyzed, conclusions are presented which are supported by the results, and additional research is recommended. It is important not to jump to conclusions in research or to otherwise skip steps in the process. It makes no sense to say I am going to do a case study or survey research for my dissertation until you know what problem you plan to address. In the next 2 slides, dissertation abstracts are presented which illustrate the idea that a clear conceptual framework including at least 2 variables must be present. Condoleezza Rice, a former U.S. Secretary of State, wrote her dissertation on party-military relations in Eastern Europe. Can you identify the problem she is addressing? What is her conceptual framework or model? What 2 variables has she identified? Would you agree that she is suggesting that Soviet policy determines the relationship between the party and the military? In an example closer to home, this dissertation addresses the problem of quality in the healthcare industry. What conceptual framework is being used in this study? What is the proposed hypothesis? Can you identify the 2 key variables being investigated? Finally, you will find these 2 dissertations in this week's reading folder. These are dissertations published by previous DBA graduates in the Baker College program. By gaining the ability to build models and conceptualize problems in a form that lends itself to research, you will take an important first step to producing a quality dissertation. In this week's class discussion forum, identify the key variables these authors are using to structure their research, and discuss what relationships the authors hypothesize among the variables in each study.
It also, another thing, has to do with the question of how do you find out if something's true? And if you have all these theories of the different religions, have all different theories about the thing, then you begin to wonder. Once you start doubting, which I think to me is a very fundamental part of my soul, is to doubt and to ask. And when you doubt and ask, it gets a little harder to believe. I can live with doubt and uncertainty and not knowing. I think it's much more interesting to live not knowing than to have answers which might be wrong. I have approximate answers and possible beliefs and different degrees of certainty about different things, but I'm not absolutely sure of anything.